Good afternoon, everybody, and thank you for joining us today. The CPD presentation is entitled Fire Stopping, Breaking the Cycle of Non-Compliance, and is brought to you by Legrand Electric Limited and Voltimum. My name's Matt Crunden, and I'm the Training and BIM Manager for Legrand UK and Ireland. Paul, could I ask you please to introduce yourself to the audience?
Yes, good afternoon, everybody. I'm Paul Moore. I'm the Area Development Manager for the Cable Management Business Unit in London and the South.
Perfect, thank you. Before we start the presentation, I just wanted to give you a very brief introduction to Legrand here in the UK. So Legrand in the UK and Ireland consists of 6 business units, and it's powered by specialist teams within each of these units. You can see them here on the screen, from assisted living and healthcare through to cable management, data communications, energy control, power distribution, and wiring devices. Our CSR strategy covers 4 distinct categories, as you can see, and in relation to today's CPD material, environmental issues and user concerns are of particular importance.
The learning objectives are here on the screen, which I'll just leave there for a moment while I take the opportunity to tell you that the seminar is fully approved for CPD purposes by both CPD UK and also by REBA.
The agenda points are shown here, and we'll be talking about quite a broad number of subjects, as you can see within the seminar, such as fire safe responsibility, cable moves, adds and changes, and a whole host of other things besides. But we'll start off with sections 1 and 2, fire protection and fire containment. Paul, could I ask you please to give an overview for us of fire protection?
Yes, of course. Fire protection has 3 critical factors. Number 1, prevent. The selection of non-flammable building materials such as bricks, steel tubing and the like. Number 2, extinguish. Once a fire is present, the actions that are required to extinguish it. This is known as active fire protection. And number 3, to contain. To prevent the fire from spreading from one building compartment to another. This is known as passive fire protection.
Excellent, Paul, thank you. Could you just briefly elaborate a little bit on the terms active and passive fire protection?
Well, active fire protection includes items such as bells, sprinklers and extinguishers, things that require motion and response. Passive fire protection, on the other hand, uses a barrier method, such as a fire door or a penetrating pathway. Let me quickly explain compartmentation too. The basis of compartmentation is to subdivide buildings into areas of manageable risk, which provides an adequate means of escape, but also provides fire separation for adjoining buildings. Compartmentation is in fact referenced within the Building Regulations Approved Document B for fire safety. In essence, for a building to function, services need to pass through fire-rated barriers.
Right, thank you for the explanation on that, Paul.
However, before choosing a fire-stopping device, it's vital to understand the requirements of the building it will be installed in. Firstly, it's important to be aware of the construction of the building and the areas within it. This is easier with a new build, as walls etc. are shown on drawings or within a model. but it can be a little bit more complicated with existing buildings. The type of wall or floor used has a bearing on the fire stopping device that you can use and will determine the fire rating. For example, 30 minutes, 60 minutes, 90 minutes, or 120 minutes.
So the slide here has a little bit of red text on it that says wall and floors are not fire rated anymore in relation to the picture on the right hand side of the slide. So what's actually going on here, Paul?
Right. For the building to be functional, openings need to be made to allow the passage of services, people from compartment to compartment. When designing the cable management pathways, consideration needs to be made as to what regulations may apply. For example, BS 8519 2010, evacuation routes.
Okay.
Decisions made at this point about allowing for future cable expansion will impact both compliance at build stage, but also the cost of maintaining the building in the future. These openings are not sealed, which is why it says the wall and floors are no longer fire rated.
Okay, so in terms of the openings in the walls and the floors, how do we restore the resistance of these walls and floors?
With the use of passive fire protection materials in accordance with building regulations Part B, section 10.2, which states the following. If a fire separating element is to be effective, every joint or imperfection of fit or opening to allow services to pass through the element should be adequately protected by sealing or fire stopping, so that the fire resistance of the element is not impaired. Using passive fire protection methods ensures that in the case of fire, the fire barrier or penetration seal stops the flames, smoke and gases from progressing to other areas. Fire is contained, the building is safe. We need to ensure that we eliminate the use of incorrect products, mispenetrations or using incompetent people to install the fire stopping, because this allows the fire to spread quickly to other areas as the fire barrier will have lost its resistance. If openings are not sealed, fire can progress to other areas. According to the Association of Specialist Fire Protection, fire will spread from one compartment to another in under 4 minutes through a hole no larger than a pencil.
Well, that's a frightening statistic. Excellent, Paul. Thank you. Let's move to section 3 and we'll talk about fire safety responsibility. What are we looking at here, Paul?
This diagram highlights the building and fire safety regulatory regime. In October 2017, the Royal Town Planning Institute, who are a not-for-profit organisation representing 23,000 planning professionals working worldwide in the public, private, charitable and education sectors, put together a short briefing to clarify who is responsible for what in England. The Building Act 1984 tasks building control with securing the health, safety, welfare and convenience of persons in or about buildings and of others who may be affected by buildings or matters connected with buildings. This includes fire safety. Fire safety is a part of building regulations, so building control plays the main role in approving fire safety in developments. However, whilst legal responsibility for assessing fire safety during development lies with building control, other systems, including planning, have roles to play too. The document sets out the respective roles and limitations in scope of each key player in this process, starting with planning. Note, this is advisory only and should not be taken to constitute legal advice.
Okay, so let's briefly examine Dame Judith Hackett's review of the building regulations, which was ordered after the Grenfell Tower disaster and has found the system, and to quote from the report, not fit for purpose.
Yes, Dame Judith Hackett's interim report into building safety has called for an overhaul of the construction industry to put safety above cutting costs. This interim report will be followed by a full report, including her recommendations expected in spring 2018. Matt, look at this map and tell me what you see, if you can see it.
Oh, I see a very complex mess. And I, for one, having actually spent some time trying to understand this, have failed.
Exactly. You don't need to see the slide or understand what's on it, but the map highlights the building and fire safety regulatory regime. This was produced in Appendix D as part of Dame Judith Hackett's interim report in December 2017. You do not need to read the text or fully understand it. I just want you to contemplate the complexity of the existing regulatory system she has identified. The purpose of the independent review of building regulations and fire safety is to make recommendations that will ensure we have a sufficiently robust regulatory system for the future, and to provide further assurance to residents that the complete system is working to ensure the buildings they live in are safe and remain so. It is examining the building and fire safety regulatory system with a focus on high-rise residential buildings. This interim report provides the findings to date and directions of travel for the review, ahead of a final report expected later this year.
Thank you, Paul. So let's move to section 4, cable moves, adds, and changes. Okay, so Paul, I have to ask you, other systems we know pass through walls and floors. So why should the fire stopping of the CMS system or the cable management system be considered separately from other systems?
Good question. Because unlike pipe or ducting, the cables on a cable support system can provide a source of fuel to propagate a fire and can also release toxic smoke and gases. You can see from the graph that a rate of combustion comparison between 1 metre of fully loaded cable tray, 1 litre of gasoline and 1 kilogram of dry wood is not at all favourable for the cable. Due to cabling being such a good source of fuel, passive fire protection is a critical factor in any electrical, data, telecom installation. Because expansion of the electrical or data infrastructure in a building is so frequently undertaken, it is the most likely source of breaches in fire stops or unprotected new penetrations of fire barriers. Some of the cables present will likely be designed to withstand the fire, but uncontained, represent a danger and a potential loss of life to those trying to extinguish it.
The ES 8519/2010 came into effect in February of that year and covers the selection and installation of fire-resistant power and control cable systems for life safety and firefighting applications. Section 15 focuses on cable installation, which we've highlighted here on the screen. And just to quote quickly from the standard, when installing cables that are required to maintain circuit integrity under fire conditions, the resistance to fire of the cable fixings, cable containment system, and any joints should be at least equivalent to the survival time required for the cable.
From the 1st of July 2013, under the Construction Products Regulation, CPR, it became mandatory for manufacturers to apply CE marking to any of their products covered by a harmonised European standard, a HEN, or a European Technical Assessment, an ETA. This was a major change in the United Kingdom, as a fixing of CE marking under the old Construction Products Directive, CPD, had been voluntary. This, coupled with some other changes introduced by the CPR, left the construction industry facing its most significant change for over 10 years in the way in which construction products were to be sold in Europe. Interpreting the Construction Products Regulation has been the main function behind the guidance note on the Construction Products Regulation, which you can see here on the screen. Since then, the European Commission has introduced further clarifications and additions to the original, resulting in a number of updates. As you can see on the slide, it's particularly relevant to cables, which now need an accompanying declaration of performance and need to be CE marked.
Okay, so Paul, there's a rather confusing table on the screen here. What's this all about?
It's not simple, Matt, but I'll try to explain and clarify. Electrical cables are rarely the cause of a fire, but when they are involved can form a seriously hazardous component because of their large quantities and because they are found in all rooms of the building. With careful preventative measures in accordance with the CPR regulation, fire propagation, the lack of visibility in smoke-filled rooms, and the diffusion of corrosive and toxic gases can be reduced or almost totally eliminated. As part of the features considered important for the safety of constructions included in the CPR, the European Commission has considered a cable's reaction to fire and resistance to fire, recognizing the importance of their behavior and role in fire situations. The release of harmful substances is one of the performances considered important for cables, although at present no minimum levels of performance have been established, because when used normally, the cables do not release harmful substances. All the cables installed permanently in constructions to transport power or for telecommunications of any voltage level and with copper or fibre optic conductors must be classified on the basis of the classes of premises where they will be installed. The table contains the classifications of cables according to test requirements of the CPR and the correlation between the cable classification and the most representative installation rooms. As well as understanding the regulatory landscape, an important consideration if fire sealing a compartment is to think about future flexibility. Working environments are often changing and evolving, and this brings its own set of factors to consider.
Okay, so there's a question that we're asking on the slide here, Paul. Why do we need to design in flexibility? So what could you tell me about the importance of that?
Well, there's half a dozen requirements here on the screen. Increases in capacity, for example, as business needs change. Extra personnel can force new layouts or new equipment, as can diversification into new markets.
But I guess that there are also some associated problems as well.
Yes, that's right. Business operation can be disrupted, including critical organisations such as hospitals, where noise from drilling and the associated dust and debris may never be considered acceptable. Areas often to be emptied to allow works to take place, and this leads to inconvenience to tenants, staff, patients, the public. There's also the risk associated with the removal of fire stopping, which is often done in order to carry out works. How long is acceptable? And then there needs to be a process in place to confirm the fire barrier has been repaired and made up to a compliant level. Another challenge is competency. How do we make sure the installer is competent? And how can we measure competency?
So a bit like the tip of the iceberg, really. This is the visible part that we can see, price of the actual product and the price to install it. However, it's clear from what we've talked about so far that there's a lot more to consider besides. Floating under the surface are the hidden costs and the risks, and we need to make sure that we're aware of those at all times. Downtime, cable damages, non-compliance, handling cost, improper installation risk, and that's just a small selection of the potential risks that one might find.
Absolutely, Matt. And here's a little example from downtime through to improper installation risk.
As we can see on those points there. Okay. Section 5, types of fire stopping systems. Let's have a look and see what's out there. So, now we have discussed what a cable pathway fire stop is to do in essence, but what kind of systems are available?
There are a number of different fire stopping systems available to the specifier, which are readily available through the supply chain and have been used for many years. Where services will perhaps never be added to, for example, incoming services or water pipes, these are absolutely fine and effectively form part of the building fabric. With conventional fire stopping systems, adding or changing cables can be problematic, and as well as the points on the screen, if a fire barrier is breached, then the building is at risk until it has been repaired. Also remember that each addition to the cables incurs extra overcosts. Muffins, pillows and collars are all readily available, fairly easy to install, and can appear to offer a certain degree of flexibility, although they're not always the most cost-effective solutions. Penetrating pathways are a flexible and most cost-effective solution that meet fire stopping requirements in all market sectors, where passive fire protection is required from data centers, which have significant cabling requirements, to multi-dwelling units with single cable requirements.
Whether a building is brand new, a head office for a corporation, designed for multi-occupation or nearing the end of its usable life, or required to function 24 hours a day, such as a hospital or a data center, there will be a demand from the occupants for cable addition, especially data or telecom, on a very regular basis. It'll often be necessary for these items to pass through the fire-resistive floor or the wall.
Yes, and in order to accomplish this, cables are often added to the existing cable management system, and oversized openings are cut or drilled through alongside the existing fire stops. Cable additions often result in the removal and reduction of the fire stopping materials. Our example shows the original installation has 12 cables, maintaining the approximate fill level of fire stopping materials at around 60% full. Addition 1 increases the cables to 18, but reduces the fire stopping to around 40% full. Addition 3 adds another 7 cables, but because the penetration is still the same size, the fire stopping reduces to around 20% full, which could well be considered to be compromised. So, to maintain an adequate level of fire stopping materials when adding cables, we actually need an increase in penetration size to make sure the ratio is maintained.
Another option would be to use cable penetration seals, which we can take a look at now. In section 6,
Modern mechanical cable penetrating pathway seals allow cable additions and changes. Factory manufacturing also guarantees fire protection at all stages, and some eliminate the need for sealant or putty that in MAC situations is often removed or replaced. Cable additions in modern systems also leave no mess or dust and also cause minimal downtime, with typical installation taking just a few minutes. Some allow retrofit, which helps to save on operating expenditure, and there's no need to call out a specialist to repair. Whilst also offering no gaps in protection, future expansion or cable additions can be factored in at design phase. The BS 8519 2010 calculation can also be done at the design phase.
some cable penetration seals also have 3D BIM files available, which can help with design and analysis. So, Paul, explain to me, please, how a penetrating pathway would work.
The devices contain intumescent material within a metal container. They are designed to allow cables to be added at any time and reseal either automatically or manually to restore the fire stopping capability. In the event of a fire, the intumescent material expands and seals the penetration, which prevents fire from spreading through the compartmentation. These are some of the standards, regulations and testing relevant to a fire stopping system. Note the testing and certification.
Note also the 2 photographs. On the other side of the wall is the inside of the test oven that would be constructed to run the tests on the fire stopping products. So what do the E and I values that we're seeing here mean? For example, on the previous slide, the classification stated EI 120. So how do we explain that, Paul?
Okay, so the fire side is tested for integrity, which is E, whilst the non-fire side undergoes a thermal test, which is the I rating. The integrity E rating is likely to remain consistent however the device is used, but the thermal I rating will change depending on the type of cable used and whether the device is installed horizontally or vertically. It's important to check the certification of the device to ensure it offers at least the same EI fire rating as the fire rated wall or floor being penetrated when installed with the cable load of your design. In terms of descriptions, fire class E or fire resistance class E integrity demonstrates the ability to prevent the passage of flames or hot gases through the module, when exposed to fire on one side, and to prevent the occurrence of flames on the unexposed side. Fire Resistance Class EI offers the highest level of protection from flames, smoke and heat. This classification of fire-rated device performs to the standard of E when exposed to fire on one side, and also restricts temperature rise of the unexposed side to below the required standard. The classification is formed by putting either E or EI followed by the time in minutes that the wall or fire stopping device is approved to.
Excellent, thank you, Paul. So section 7, entitled Checklist. With potential concerns raised over current building regulations, and we've already explored two elements there from the Royal Town Planning Institute and the Dame Judith Hackett review. What do we need to consider when specifying a fire stopping system for a cable pathway between compartments?
Well, we'd like to offer a checklist as follows. Consider possible installation issues such as speed and quality of workmanship. Consider how to minimize the potential of poor installation and need for detailed invasive inspection. Consider requirements for future and ongoing maintenance and regular inspection. Future flexibility, choosing a system that automatically adjusts to the number of cables installed, ensuring fire protection with every new or retrofit installation. Specify a proprietary product, ensure it is fully compliant with all standards and testing, including BS 476 Part 20 and EN 1366-3. Specify a design that assures it is fire stopped at all stages, whether it is full or empty of cables. Does the system meet the fire rating requirement? For buildings running 24/7, consider a system which reduces noise and debris. Consider a system which removes any handling or removal of fire stop material. And look at the acoustic issues between compartments, 45 decibels and above. Consider a system that can maintain segregation to ensure electromagnetic compatibility. Shown here on the next slide are some good examples of fire stopping. The cables are neat and tidy, gaps are sealed, and visual inspection can be carried out easily. And on the next slide, some that are not so good.
Paul, seriously?
They're all actual installations, believe it or not.
Okay. With those last two slides in mind, let's look at some standards and regulations.
New Wiring Regulations 2018. The draft for public comment closed near the end of August 2017, and the joint IET BSI subcommittees are reviewing all the comments which have been made. The latest revision of the IET wiring regulations, BS 7671, the 18th edition, come into full effect in January 2019.
Excuse me. And these are some of the relevant standards and regulations covering the seminar subject today.
Because we need to prevent this from ever happening again. This is the Windsor Tower in Madrid, which during a refurb in 2005, a fire started on the 21st floor, which rose through the riser up to the 41st floor. Fortunately, nobody was killed in this.
This was a cable fire, I
Yes.
believe. Okay. Section 9, the summary, followed by 10 and 11 for the learning and the Q&A. Paul, I'm bravely going to pass the summary to you.
Thank you, Matt. We should now have a good understanding of the importance and relevance of fire stopping cable pathways, as we've spent some time discussing the factors involved in order to achieve successful fire protection and containment. Cable moves, adds and changes, or MAC, can be problematical, as we've demonstrated, but we should now be able to understand the need for future flexibility. Different types of cable pathway fire stopping systems exist in the marketplace and can be identified relatively easily. We've given an overview of national and international testing, certification, standards and regulation, and also taken a look at the complex nature of fire safety responsibilities. This will change in the near future once Dame Judith Hackett's final report is published. Sharing solutions is one of the best ways to learn best practice and will help us all to understand non-conformance and how to break the cycle.
Terrific, thank you, Paul. So for further sources of information on today's seminar, and of course as a source of further study and learning, please refer to the following website you can see here on the screen. And any further queries, please contact the Legrand team. You can reference another set of information there on our website, www.legrand.co.uk.
Now on to the Q&A before we close.
Okay, let's just here. There's just a few questions in there at the moment, so we'll just go through these. So the first one is asking, how does the cable management go through the penetrating fire barrier?
The cable management doesn't actually go through the penetrating fire barrier. It would stop beforehand. The cables are fed through and then pick up the cable management the other side of the cable penetration.
Because it's a sealed unit.
It's a sealed unit, yes.
So cable management stops, Paul, to be clear, either side of the wall or the floor.
Absolutely.
The unit goes through, that carries the cables through it and picks up the cable management on the other side.
That's correct.
Perfect. Okay. Okay, the next one, you mentioned BIM files. Yes, we did. Do you have Revit files? Yes, we have. So on our website, you can download the Autodesk Revit files for the for our fire stopping system. So you'll download a small family of components, and those components mirror the offer that's available in our catalogue, our brochure. You'll find a user guide in there as well. You'll find some photographic images, various things that you can use to enhance your project. But you'll be able to use those Revit files to aid with design or analysis and various other things afterwards, and also generate a bill of materials as well. How hot does the incandescent material need to be for it to activate? Good question. So there's two factors on this one. There's the heat itself, and there's exposure to the flame. So the incandescent material will activate if it's either exposed to direct flame or the heat reaches 177 degrees C or above, and then it'll activate and seal the pathway. how can I get training for my team to carry out fire stopping repairs? Is there a qualification available? Martin, is an excellent question. There are various organizations out there that you can easily find on the internet that will give fire stopping training. We as a business, as Legrand, are currently putting the final touches to some training courses on fire stopping, in particular with the penetrating pathway. So keep an eye out for that, and obviously we'll keep your details on record for that. And once that course is ready, then we can be in touch. But that's currently something that we are looking at right now. Okay, Martin again is just asking if there is a qualification, where can I get the training? It's interesting that the electrical industry probably shares skills. So what I mean by that is we might have fire stopping installers working in the same space as the electrical installers. So we kind of share that resource. So there are opportunities, as I say, have a look on the internet, have a look at some fire stopping training. There are some places where you can get that. It just needs a little bit of a search. Carl's asking, how does this relate to domestic dwellings? What fire rating time would you expect to design and rewire, say, 1925 house? What products are available for domestic installs? Okay, again, good question. In terms of the seminar and the product that we've really been talking about and the penetrating pathways, if you recall what we were talking about around the Dame Judith Hackett review, that is particularly geared towards high-rise dwellings. So we're talking apartment blocks. So yeah, fire testing, fire rating, all of the subject matter of this particular seminar is absolutely relevant to that kind of installation. In terms of rewiring, say, a 1925 house, this product, I think it would be highly unlikely that it would be installed in something like that. Do you have any feelings on domestic installs, Paul?
No, the only suggestion I would make was maybe the cable grommet for single wires for data or for the TV installation cabled.
Right. Yes. Okay.
But for, as I would agree with you on the general cabling.
Okay. So is there anything else on there? Let's just have a look. Here's a PDF of the presentation that you can download. So take some time to click on the button and get that for your files. Any more questions come through? Okay. So unless there's any quick ones that come through now, we'll draw a close. And I guess it just leaves me to thank you for tuning in and having a look at what we're offering. And thank you to Paul for joining me today. Any last comments, Paul?
No, thank you very much. It's been a pleasure.